Sleep's mysteries have puzzled scientists for centuries. Now in laboratories around the world, some of these mysteries are being solved as people sleep attached to recording devices while others observe. By recording the brain waves and muscle movements and watching and sometimes even waking sleepers, researchers are glimpsing things that 1,000 years of common sense never told us. So in the course of this little lesson, I hope to help you answer these following questions. First, what is the circadian rhythm and what are the stages of our nightly sleep cycle? How do our sleeping patterns differ and why do we need sleep? And how does loss of sleep affect us and what are the major sleep disorders? Okay, like an ocean, life has rhythmic tides. Let's look more closely at two of these biological rhythms. We have our 24-hour biological clock that we'll talk about first, and then we will talk about our 90-minute sleep cycle. So the body is kept roughly in tune with a 24-hour cycle of day and night by our internal biological clock called the circadian rhythm. So this is our biological clock. It corresponds to 24 hours of a day and night cycle. It includes regular body rhythms of wakefulness and changes in body temperature. As morning approaches, the body temperature rises as we're waking up and then peaks during the day. It dips for a time in the early afternoon, which is normal. That's the time when we feel like we're kind of ready for a nap. And then it begins to drop again in the evening as we're preparing to go to sleep. Thinking is sharpest and memory is the most accurate when we're at our daily peak in the circadian arousal. Also, age and experience can alter our circadian rhythm. So sleeping is a periodic, natural loss of consciousness, which is different than the unconsciousness that results from things like a coma, general anesthesia, or else hibernation. Sooner or later, sleep overtakes us and consciousness fades as different parts of our brain's cortex stop communicating. But instead of emitting a constant dial tone, the sleeping brain has its own biological clock. We have sleep stages that we'll be talking about next. There are 4 identified stages of sleep. There are 90 to 100 minutes to pass through the 4 stages. This is our sleep cycle. The brain waves change with the stage of sleep you're in. And the first 3 stages are called the NREM sleep, or non-rapid eye movement sleep. And then the 4th stage is called the REM sleep, or rapid eye movement sleep. First, let's talk about brain waves. Beta waves, these are the waves that we have in our brain waves when we are wide awake. Alpha waves are the brain waves that are slow and relaxed. They are when we are awake, but this is when we're starting to relax and get ready to go to sleep, or in our first stage of sleep. We also have delta waves. The delta waves are large, slow waves of deep sleep. When we are in our deepest stages of sleep, we have these large, slow waves of deep sleep. And also during the stages, we have hallucinations. We have hallucinations during the first stage of sleep as we are starting to drift. And so these are false sensory experiences. That's what hallucinations are. You might feel like you see somebody or talking to somebody and really you're not. And sometimes in that first stage, people don't even realize that they're sleeping. And then we have the sleep spindles, which is beginning, it consists during the stage 2 of our sleep. And this is some rhythmic brain activity, rapid rhythmic brain activity. So let's talk just a minute about a couple of the major waves that we're going to experience the most in our wakeful states. We have the beta waves. These are present when we are in alert waking state. During strong mental engagement, the brain exhibits low amplitude and fast, irregular beta waves. So this is when we are in an alert, wakened state. And we have the alpha waves. These are when we are in a relaxed, awake state. So when an individual closes his eyes but remains awake, his brain slows down to a large amplitude and slow, regular alpha waves. So during early light sleep, This is stage 1. The brain enters a high amplitude, slow, regular waveform. So we start out with these slow, regular waves of alpha waves. The person who's daydreaming shows these type of brain waves. During this stage, hallucinations may be experienced, and it's common to experience a floating or falling feeling. So during the stage 2, this is when we experience the bursts of brain activity, and this is when we are clearly, truly asleep. During stage 3, this is the deepest sleep stage experience. The brain activity slows way down. There are large amplitude, slow brain waves. At this point of sleep, it's difficult to awaken the sleeper. Toward the end of stage 3 is when we usually see sleepwalking and talking and bedwetting in children. And then last of all, after we reach the deepest stage, the sleep cycle starts moving backwards towards stage 1. Although still asleep, the brain engages in low amplitude, fast and regular beta waves, much like an awake and aroused state. During this stage, it's called the REM sleep, or rapid eye movement. In this stage of sleep, the brain's motor cortex is active. The body is in a state of paralysis, which means they cannot move. Except for the eyes, there's a lot of rapid eye movement going on. The eyeballs are moving all over underneath those eyelids. But the spinal cord will not allow any messages to go down to the parts of the body. That's why we're in that paralysis. And during this stage, people report having very vivid dreams. So why do we sleep? We spend about a third of our lives sleeping. If an individual remains awake for several days, they deteriorate in terms of like immune function, concentration, and there's going to be a lot more accidents. So let's talk about the functions of sleep. First, we have restoration. Okay, so sleep helps restore and recover brain tissue. The body wears out during the day, especially the brain needs a little bit of a break, and sleep is necessary to put it back into shape. It's almost like when consciousness leaves our house, the brain construction workers come on in for a makeover. Next, sleep protects. It's for protection. Sleep emerged in evolution to preserve energy and to protect. Back in the day, darkness meant danger and death. Those who did not go out did not die. So basically, with our early ancestors, when darkness shut down the day's hunting, the food gathering, and travel, our distant ancestors were better off sleeping in a cave out of harm's way. Those who didn't try to navigate around the rocks and cliffs were mostly likely to leave descendants. So it's a way of protection. Also, sleep helps remembering. During sleep, we restore and rebuild our memories of the day's experiences. People trained to perform tasks recall them better after a good night's sleep, or even after a short nap, than after several hours of awake. Sleep strengthens neural memory traces and makes them more stable. So maybe instead of staying up till 2 o'clock in the morning to study for that test, it would be great to study for a while and then get a good night's rest. Also, sleep supports growth. During sleep, the pituitary gland releases hormones that we need for muscle development. A regular night's sleep can improve our athletic ability. New babies sleep so often for one reason. They are growing. They're constantly growing. So newborns sleep about 16 hours a day. And older people release less of this growth hormone, and so they need less sleep. So here's an example of sleep over the lifespan. And as you can see, when we're in those stages of the most growth, that's when we require more sleep. And this is the average daily hours of sleep for different mammals. The humans are right there, kind of in the middle. Okay, so there are some really bad effects of sleep deprivation. If you do not get enough sleep, these are things that you will probably be experiencing. Fatigue, feeling tired all the time. Impaired concentration, you have a hard time concentrating on things. Your mind keeps wandering. Immune suppression, you easily catch illnesses. Irritability, you won't be as patient. You'll be easily annoyed. Slow performance, and this is very dangerous when we talk about taking care of heavy machinery or any kind of machinery for that matter, driving vehicles and things. We have an increased rate of accidents for people that do not get enough sleep. So no matter what their normal need for sleep, some 1 in 10 adults and 1 in 4 older adults complain of what is called insomnia. So we're moving on to the sleep disorders. Insomnia is reoccurring problems falling or staying asleep. Now, most of us have problems from time to time falling asleep, but this is when it's reoccurring. If it's a regular problem, then you may be suffering from insomnia. Another sleep disorder that we need to talk about is narcolepsy. So sleep is not a problem for people with narcolepsy who have sudden attacks of overwhelming sleepiness, usually lasting for about less than 5 minutes. But they will fall asleep very quickly, very frequently. So it's characterized by uncontrolled sleep attacks. Another sleep disorder is sleep apnea. So this is characterized by it puts millions of people, about 1 in every 20 of us, at increased in traffic accidents. People with this condition stop breathing over and over again. After an airless minute or so, their blood oxygen is so low it awakens the person just long enough to draw breath. Sleep apnea is linked with obesity, loud snoring, daytime sleepiness, irritability, and high blood pressure. A mask-like device with an air pump can relieve sleep apnea symptoms. Another sleep disorder is night terrors. Night terrors are different than nightmares. Both night terrors and nightmares happen typically in stage 4 of sleep. But night terrors are characterized by high arousal and an appearance of being terrified. In children with night terrors, it's very difficult to wake them up, but in the morning they have no idea what happened. They don't remember the terror that they had. So this stage, it occurs in stage 4 of our sleep cycle.